Hello everyone! Today we will learn about addition of integers. But before that, let's have a recall about integers. Integers are any of the natural number, it's negative and 0. So numbers such as positive 10, negative 7, positive 4, and negative 13 are examples of integers. Now let's go back to addition of integers. So one device that will help us in learning how to add is the algebra tiles. Now what are algebra tiles? Algebra tiles are mathematical manipulatives that allow students to better understand concepts of algebra in a concrete way. How does it work? So a positive tile or a blue tile represents positive 1 and a red tile represents negative 1. A pair of a blue and a red tile makes a zero pair, or a pair of a positive and a negative tile makes a zero pair or equal to 0. So you will only count those tiles without a zero pair, and that would be the sum. So for you to understand better, let us have some examples. So first, add 6 plus 7. So first, we model the addends. Our first addend is 6. Since 6 is a positive, we use blue tiles. And we have 1, 2, 3, 4, 5, 6, and our second addend is 7 and still a positive, so we use blue tiles, 7 blue tiles. Now the next step in adding integers using algebra tiles is we count the tiles without a zero pair. Now since all the tiles are blue, there are no zero pairs, so we count them all. So we start from the 6 tiles added by the 7, which is now 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10, 11, 12, and 13. So since it is all blue tiles, the answer is positive 13. Therefore, 6 plus 7 is equal to 13. Now let's have our second example, which is negative 3 plus negative 5. First, we model the addends. Our first addend is negative 3. Since it is a negative, we use red tiles. So we have 1, 2, 3 red tiles. And for our second addend, which is negative 5 and still a negative, we use red tiles. So negative 5, 1, 2, 3, 4, and 5 red tiles. Now the next step is to count the tiles without a zero pair. Also, this one has all red tiles, so we just count them all starting from 1, 2, and 3, added by again 4, 5, 6, 7, and 8. So there are 8 red tiles, so that means our answer or our sum is negative 8. Therefore, negative 3 plus negative 5 is equal to negative 8. Now let's have another example. So add 5 plus negative 2. Again, we first model the addends. Our first addend is positive 5. Since 5 is a positive, we use a positive tile or a blue tile. So 1, 2, 3, 4, and 5. Our second addend is negative 2. Since it is a negative, we would use a red tile. So 1, 2, 2 red tiles. Now the second step is to count the tiles without a zero pair. So as you can see, there are 2 zero pairs. Now let us count the tiles without a zero pair. We have 1, 2, 3 blue tiles. So that means our sum would be a positive 3. Therefore, 5 plus negative 2 is equal to positive 3. Now, here's another example. Add 3 plus negative 7. So first model the addends. Our first addend is positive 3, so we will use blue tiles. So 1, 2, and 3. Our second addend is negative 7. Negative 7 is a negative, so we will use a red tile. So 1, 2, 3, 4, 5, 6, and 7. Now the second step is to count the tiles without a zero pair. Now as you can see, there are 3 zero pairs. Now count the tiles without a zero pair. We have 1, 2, 3, and 4 red tiles. So that means the sum is a negative 4 since there are 4 red tiles. Therefore, 3 plus negative 7 is negative 4. Now, let's go back to examples 1 and 2. So, what do you observe with the addends? So, in example 1, we are adding a positive and a positive, and the answer is positive. While in example 2, we are adding a negative plus a negative, and the answer is a negative. So we are adding the same signs. And the answer is also the same signs as the addends. And we can say that in example 2, we are just like adding their absolute values. For example, the absolute value for negative 3, which is 3, added to the absolute value of negative 5, which is 5, is equal to 8. And they have the same negative signs, and the sum is 8, and the negative was being copied. So therefore, we can conclude that in adding like signs, we will add the absolute value of the addends and copy the common sign. Now, how about examples 3 and 4? So we are adding a positive and a negative, and the answer is a positive. While in example 4, we are also adding a positive and a negative, but the answer is negative. So what have you noticed? Getting the absolute value of example 3, which is 5, and negative 2, we are like subtracting them to get 3. So why positive? To know why is it positive, let's also look for example 4, getting the absolute value of 3 and negative 7. We are also subtracting to get 4. But the sign for the sum is in negative. So why do you think it is negative? So as you can see in example 3, the negative sign is on 2, and 2 is lesser than 5. In example 4, the negative sign is on 7, and 7 is greater than 3. Therefore, we can conclude that in adding different signs, we will subtract the absolute value of the addends and copy the sign of the addend with a greater absolute value. Now, for us to know if our rules really works, let us have an example of negative 15 plus negative 8. In here, you can see that they have same sign, so we add their absolute values. Taking their absolute values, we have 15 plus 8. So 15 plus 8 is equal to 23. Now the common sign is negative. Therefore, we copy the negative sign And the answer for negative 15 plus negative 8 is negative 23. Now another example is add negative 13 plus 5. As you can see, they have different signs, so we subtract their absolute values. Taking their absolute values, we have 13 and 5. Since we are going to subtract, it would be 13 minus 5. 13 minus 5 is equal to 8. Now the sign of the greater addend, which is negative 13, is negative. Therefore, our answer is negative 8. The answer for negative 13 plus 5 is negative 8. Again, the rule for adding same signs is you add the absolute values and copy the common sign. While in different signs, adding integers with different signs, you subtract their absolute values and take the sign of the greater addend. I hope that you have learned something, and thank you so much for listening. Have a good day.